Hey everyone. Okay, we're still talking about 2.5a. We're still looking at graphs of sinusoids, just now we have a happy dog. Okay, we're going to talk about how we can graph sinusoids from some sort of equation, okay? So there's kind of like 3 steps that are going to make this process a little bit easier. So first we're going to find the period. So again, remember finding the period. I like to take 2 pi and then multiply by that horizontal stretch or compression. Okay, so basically we need to know like what our range is going to be to make one full iteration of this. Next thing that we're going to do, once we know what that period is, we're going to divide the period by 4 to use for intervals because we're going to make a table, okay? The reason that we're dividing by 4 is because our goal is to try to mimic finding the quadrantal angles. So for instance, you don't need to turn back, but I'm going to scroll back up. When we were initially finding or graphing this an original function, the parent functions, there were some values that gave us like really nice values to graph, right? And that came from like these, so like 0, pi over 2, oops, not that one, how do I erase that? Pi, 3 pi over 2, and 2 pi, okay? So those were those quadrantal angles, and when we had those and plugged those in, we got nice values of like 0, 1, and -1. We're going to try to mimic that process, and so to do that, we're going to need to find 1, 2, 3, 4 intervals to do that, okay? So that's our goal. Where are we at? Okay, then we're making a table and we're evaluating using the unit circle. So basically once we have our table, we're going to plug things in and we're going to find some outputs and then we're going to graph it and we're going to be happy. Okay, before we do that though, I am going to introduce one new vocab word. The new word is frequency, okay? The frequency of a sinusoid is the number of complete cycles the wave completes in a unit interval. And to find that, the frequency is the reciprocal of the period. So basically remember the unit interval was 2 pi. So we're trying to figure out, well, in that 2 pi initial unit interval, how many times did we go back and forth? And we saw an example of this actually back here. Here, we went through 1, 2, 3 intervals within that 2 pi. So our period, that's what our frequency would have been. So our frequency would have been 3 over 2 pi. And the way that we would have thought about this is we made 3 cycles within the 2 pi unit interval. Okay, let's get going with this. Okay, so we are finding the amplitude, period, frequency of the function, and we're using this information to sketch a graph. Okay, we're looking at example A here. So our function is 3 cosine of x over 2. So first, let's go ahead and find that amplitude. That amplitude's just our vertical stretch or shrink, which is 3. Okay, next up, we're going to find our period. So remember, I might rewrite this a little bit. So this is 3 cosine, our coefficient on x is 1/2 x. To find our period, I like to find our horizontal stretch or shrink. So horizontal, let's see. So this number is 1/2. So we're going to have a horizontal stretch. So we have a horizontal stretch of 2. And so then to find our period, I'm going to take 2 and I'm going to multiply by 2 pi. So our period is 4 pi. Okay, to find our frequency, like we saw up here, it's just the reciprocal of the period. So that's going to be 1 over 4 pi. And so the way that I'm thinking about this is we are going to make one full circle within a 4 pi unit interval, okay? Or we can also think about this as 1/2 times 1 over 2 pi. So we're making half of a cycle within that unit interval of 2 pi. Okay, so basically like we're really stretching this out. Instead of like a normal 2 pi, it takes us half the time to get there. Okay, so we've really stretched out. All right, okay, so we now need to divide our period up because we're going to make a table and we're going to plot some values, okay? So our period is 4 pi. We're going to divide that by 4. So that means that we're going to go by intervals of pi. Okay, and then you might want to write small. I'm going to write over here. We're making a big table, okay? So we have our x values and then we have our y values. And our function is 3 cosine of x over 2. Okay, so I know we need to get to 4 pi. So let's divide it up. So we're going to go by intervals of pi. So 0 to pi, 2 pi, 3 pi, and 4 pi. One thing just to note, and I always have to remind myself with this, you're going to need 5 points, even though you're making 4 intervals, because, like, here's 1 interval, 2 interval, 3 interval, 4 interval. Okay, so, but you do need 5 points, not 4 points. Oh, no, everything went away. Okay, now that we have these points, we are going to plug them into our function. So first up is 0. So I'm going to have 3 times cosine of 0 over 2. Okay, well, let's simplify. So 3 cosine, that's going to be of 0. So when our radian is 0, what's our cosine value? That's going to be 1. So 3 times 1 is going to give us 3. Okay, same thing for pi. So now we're going to have 3 cosine of pi over 2. Well, pi over 2 using our unit circle is up here. What's our cosine value? It's 0. So 3 times 0 is 0. Okay, plugging in 2 pi, we're going to have 3 cosine of 2 pi over 2. Okay, that's going to be 3 cosine of pi. At pi, that's here. Our cosine value is -1. So 3 times -1 is -3. Plugging in 3 pi, 3 cosine 3 pi over 2. Let's see, 3 pi over 2 is down here. Our cosine value is 0, so 3 times 0 is 0. And then 4 pi, I should theoretically get back to the same value that I had at the start of this, but let's just double check. Okay, so we have 3 cosine of 4 pi over 2. That's 3 cosine of 2 pi, and yeah, we are back to 1, so 3 times 1 is 3. Okay, so we now have our input out values, we have our output values, we now just need to graph this. So one thing that's going to be really important with this, even more so than the other ones, is we do need to really label our scale. Okay, so here I see that my points are going by pi, so I'm going to have pi, 2 pi, 3 pi, and 4 pi. Okay, so let's plot our points. So at 0, we are at 3. At pi, we are at 0. At 2 pi, we're at -3. At 3 pi, we're at 0. And at 4 pi, we're at 3. So then plot, connecting our points. It looks something like this, okay? Now, we do only have half of this, right? We have 1 period. And I do think, did it say over here? Okay, well, it said to sketch a function in the window -4 pi to pi, so I do want to sketch the other half of it. Okay, a couple different ways that we could do it. So first, I know that if I'm going the other way, well, now I have -pi, -2 pi, -3 pi, and -4 pi. But the good news is that these should actually be pretty easy, because I know since this is periodic, it's just going to repeat itself. So if I'm looking at like -pi, for instance, well, -pi is going to be right here. Okay, well, that's back at -1, so 3 times -1 is, no. Yes, wait, hold on. What? Okay, sorry. When we're doing this, I have to remind ourselves. Okay, so if we plugged in -pi, I'm getting ahead of myself. Not in order, but let's just do -pi down here. Okay, I'm going to have 3 times cosine. Here we go. Make sure you plug it in. -pi over 2. Okay, well, -pi over 2 is not this point. It is this point. Okay, right? Because we're going the opposite direction. So cosine of -pi over 2 is 0. So 3 times 0 is 0. So we're back here. And I do see that it's just going to repeat itself, right? Because I'm going here. So I'm just going to reflect all of these points over and graph them and connect them. There we go. There we have it. So I always like to kind of look at a visual just to kind of see what we're looking at. So like we were looking at cosine. Let's make sure that we're back in radians. Okay. Here's our graph. So if I'm looking at, let's just restrict our domain. Let's go to x-axis. We want to go to like, let's see, 4 pi. Here, let's just start at 0. Okay, so I see that our red is our initial cosine graph, and I see that we could make one period and then two periods. So we got two iterations in. Whereas like here, I could only make one long one. So I was able to make two of those within that full version. Or I think that I got halfway through a normal period on like our new graph. Okay, sweet. We're gonna skip this one for now. The next one I want to do, and this might just be a little bit different in your notebook in future years, we're going to do example B here. So our next one that we're doing is y equals -3 sine of x, okay? And so our directions are we're graphing two periods of the function. We're using our understanding of transformations and not our graphing calculators, okay? And we're going to show the scale. So here, yeah, okay, it doesn't make us necessarily state what all of our stuff is, our period, our amplitude, anything like that. But let's just kind of state the things that we know, okay? So for instance, I know that we're going to have an amplitude of 3, okay? Not -3, because what does that negative mean? We're reflecting over that x-axis. So I might just write that also. Okay. One thing that I am going to need is my period, right? So our period comes from that horizontal stretch or shrink, and then we're going to multiply 2 pi by it. So, okay, well, if I'm looking here, well, I don't see any coefficient on x except for 1, so that means that we are not horizontally stretching or shrinking, so that means that our period is just going to be 2 pi, okay? Sweet. So now what we're going to do is we are going to make our own table again. So let's take 2 pi, and we're going to divide it by 4. So we are going to be going by intervals of pi over 2. Okay. Make yourself a table. Okay. Whoa, I wrote pi over pi. That's silly. Pi over 2. Okay. So I'm going to have 0, pi over 2. Okay, well, what's another pi over 2 added to that? It's 2 pi over 2, so that's pi. Add another pi over 2, we're at 3 pi over 2. And then we're at 2 pi. Okay, so there's my whole period. Okay, let's plug in these values. So I'm going to have -3 times sine of 0. Okay, well, my unit circle's up here, but we should kind of have these memorized. I just like to draw myself this. Okay, so sine of 0 is here. What's our y value there? Our y value is going to be 0. Okay, if I plug in 2 pi, I'm going to have -3 times sine, pi over 2. Okay, pi over 2 is up here. Sine is 1 there, so it's -3 times 1. Okay, plugging in pi, I'm going to have -3 times sine of pi. Pi is right here, so sine of pi is 0. Draw 0. 3 pi over 2. So that's down here. So sine of 3 pi over 2 is -1. So -3 times -1 is going to give us +3. And then back to 2 pi over here, we should be back to 0, but let's just double check. Yep, we're back at 0. All right, okay, so we need to go ahead and label our axes. So in this case, our intervals, we're going by pi over 2, so that's what I'm going to count on my axes. Pi over 2, pi, 3 pi over 2, and 2 pi. Okay, and then we're going to count by 1, 2, 3. Okay, let's start plotting our points. Here we go. Okay, so 0, 0. We have at pi over 2, we're at -3. At pi, we're at 0. At 3 pi over 2, we're at +3. And then at 2 pi, we are at 0. Okay, so our graph looks like this. Okay, and I know that that is just one wave of it, so I know that it is going to keep going in the other direction, so we should be something like this. Okay, I might put arrows at the end of mine because I do know that it keeps going, right, because it's periodic. Okay, I'm going to head over to Desmos. Let's look at our graph. Okay, so this time we were looking at sine, and we were at -3 sine of x. So here we go. So this is my 2 pi period. Nope, this is my 2 pi period. That was 4 pi. Okay, so I know that the scale looks weird, and it's because my y scale is kind of odd, so let's just make this go by, not by this, what do I want to do? Let's go -4 to +4. Okay, close enough. So it looks kind of weird because on the horizontal axis we're going by radians, and then the vertical axis we're just going by units, like 1, 2, 3, 4. But this is what it looks like. So the purple is our normal sine of x. I do see that we have that amplitude of 1. And then on the green we have that amplitude of 3, so it's 3 times as tall. I also do see that we have our reflection, so we've reflected over the x-axis as well, but we did finish in that same period, so we were able to get a full wave in 2 pi. Okay, I do want to look at one more example here, and your notebook might say that it's in section 2.5b. I'm actually in the future going to move this to 2.5a, so just go ahead and ignore that, okay? If it does say that, you're in the right place. Okay, I do want to look at example B. So we're going to state the amplitude and the period of the sinusoid, and we're going to find the phase shift and the vertical translation, and we're going to graph it. Okay, so example B, we have y equals 2 cosine of 2 pi x minus pi minus 1. All right. So our amplitude is going to be just that coefficient that's out in front. That's going to be 2. Okay, so it's twice as tall as a normal cosine. Our period, okay, so remember our period comes from the horizontal stretch or compression, and then we're going to multiply it by 2 pi. So that's going to be that b value here. So here's my horizontal stretch or compression. Since it's 2 pi, if I think about what kind of number 2 pi is going to be. 2 pi is going to be a number that's bigger than 1, right? So I know I'm really going to have a horizontal compression of 1 over 2 pi. Ooh, that's weird. We haven't seen that before. Okay. So if I want to find my period, I'm going to take 2 pi. I'm going to multiply by 1 over 2 pi. So our period is actually 1 in this case. Okay. Our phase shift now is going to be how much we go right or left. Okay, so to find our right or our left movement, I know that I'm going to look at this value here, but remember, there's that condition. We do need to make sure that the number in front of x, or our coefficient on x, is 1. So we do need to factor this. So I'm going to have 2 cosine. Okay, well, I see that both of these have a pi, but I also need to pull out that 2 pi, okay? So that is going to make what's in here a little bit weird. So I'm going to have x minus, well, if I've factored out a 2 pi, I'm really taking pi and I'm dividing it by 2 pi. So I'm going to have x minus 1/2. And then we have minus 1. So our phase shift is going to be, looks like we are going right 1/2. Okay, and then our vertical translation just comes from that number at the end. We're going -1, so we're going down 1. All right. Okay, so we need to graph this. So we need to find our period divided by 4. So our period is 1. So 1 divided by 4 is 1/4. Okay. So that's what we're going to have here. Okay, let's make ourselves a table. I'll just make my table. Make my table over here. Okay, x and y, and our function was, let's see, 2 cosine. You can either use the factored version or the non-factored version. It's totally up to you. I'm going to use non-factored. Sweet. Okay, here we go. So we're going by values of 1/4, right? So I'm going to have 0, 1/4. Let's see, another 1/4 makes that 2/4, which is really 1/2. I just wrote 1/4. 1/2. There we go. Plus another 4th is 3. I keep wanting to write a pi. 3/4, and then 1. Sweet. Okay, so we're going to start plugging these values in, and we just need to evaluate. So for 0, I'll have 2 cosine. So I'm going to have 2 pi times 0. Well, that's just 0. So 0 minus 1, or 0 minus pi minus 1. Hopefully you give yourself enough room. We're going to have a lot of calculations. Okay, so 2 times cosine of -pi minus 1. Okay, so here's my unit circle. -pi is going to be over here. So cosine of -pi is -1. So I'm going to have -2 minus 1. So that's -3. Next up, let's plug in 1/4. So I'm going to have 2 times cosine. Okay, so I'm going to have 2 pi times 1/4. That's going to be pi over 2. I'm going to have pi over 2 minus pi minus 1. Let's see, so pi over 2 minus pi is going to give me negative pi over 2. Minus 1, okay. So cosine of negative pi over 2, okay, so here's negative pi over 2. Well, cosine 0 there. So I'm going to have 0 minus 1, which is negative 1. Okay, plug in 1/2. Switch colors. Okay, so I'm going to have 2 pi, hold on, 2 cosine, okay, 2 pi times 1/2. Just gives me pi. So I'm going to have pi minus pi. So that's 2 cosine, pi minus pi is 0, minus 1. Okay, so cosine of 0, here's 0. Cosine of 0 is 1, so 2 minus 1. Which gives me 1. Okay. Here we go. 3 over 4. So I have 2 cosine. Okay, so plugging that in. So I'm going to have 2 pi times 3 over 4. So that's equal to 6 pi over 4, which reduces to 3 pi over 2. Okay, so it reduces to 3 pi over 2, but we still have to subtract out that pi. I knew I was forgetting something. Okay, 2 cosine. Okay, so we have 3 pi over 2 minus pi. So that's like 3 pi over 2 minus 2 pi over 2, which is just going to be a singular pi over 2. Okay, so cosine of pi over 2 is up here. Cosine of pi over 2 is 0, so 0 minus 1 is negative 1. Okay, and then I should get back to like some sort of 3 value here. Let's just double check though. So I'm going to have 2 cosine. Okay, so now x is equal to 1, so it's 2 pi minus 1. So that's 2 cosine of pi minus 1. Well, here's pi. Yep, that's still negative 1, so I have negative 2 minus 1 is negative 3. Ooh, all right, lots of good stuff going on here. Are we having fun yet? Let's go ahead and start graphing all of this. So my y-axis is already graphed. Let's go ahead and label the x. I know this is going by ones. It's going to be really squished if we just do each one as one. So let's maybe have this be 1, 2, 3, 4, but it's totally up to you. Okay, so let's plug it in. So when x is 0, y is negative 3. When x is, wow, what did I do? 1, 2, 3, 4. Can you tell I'm tired? Here we go. 1/4, 1/2, 3/4, and 1. Okay, let's try that again. When x is 1/4, we're at negative 1, so I have a point here. When x is 1/2, we are at positive 1. We're here. When x is 3/4, we're at negative 1. And when x is negative 1, we're at negative 3. All right. Okay, so this is the cosine graph. I know it kind of looks like just like an absolute value here, but we do kind of have like a little bit of a concavity change, just a little bit. Ish, yeah. Okay. And then I do know since it's periodic, I'm going to have the same thing on the other side. So something like this, yeah. And then arrows on the end. Okay. Finally, let's go ahead and look at Desmos. So we're comparing this to the original cosine graph, and then here is this. Ooh, okay, so our period was, 1? So let's just make this go to 1. Yeah, okay, so this is what it looks like. So we've done a lot of stuff to our normal graph, right? So, like, we had this on our graph that we made, but this is what it looks like in comparison to just, like, our normal cosine. So, like, our normal cosine, let's change our y-axis. Let's do -5 to 5. There's our negative cosine. That's what we just graphed. So, like, we are, like, very, very frequent. Like, we have a lot of stuff going on. We have a high frequency, right? Wow. Okay. So, this is graphing our sinusoids graphs. We're going to do more with this in class, but I will see y'all later.